Part 2 of Unit 1 is details about atoms and basics about interactions between them. Here we've got a picture of a carbon atom that's illustrating the three parts of the atom: the positive proton, negative electron, and the neutron that has no charge. Even though these three parts look like they are the same size in this picture, this isn't necessarily to scale. Protons and neutrons are roughly the same size, but electrons are a lot smaller. Their mass is several orders of magnitude lower than protons and neutrons, so just remember that this is not to scale. In this carbon atom, we've got 6 protons and 6 neutrons, and 6 electrons. Those electrons are balancing out the positive charge from the 6 protons, so this carbon atom is neutral. It's got no charge. If we were to take one of these electrons away, so let's say this electron gets taken by some other atom, we're left with 6 protons and 5 electrons. That would give this carbon atom a charge of positive 1, because it would have one more proton than it would electrons. Now, if we were to add 2 electrons to this, let's just say he picks up 2 extra electrons from another atom, it would have 8 electrons and 6 protons. So it'd have 2 more electrons than protons. That would give the carbon atom a charge of -2. So that's how we calculate the charge of different ions. If an ion is positive, it's called a cation. If it's negative, it's called an anion. The easy way to remember that, if you look at the word cation, the letter T looks like a plus sign, and plus sign means positive. So if it's got a positive charge, it's a cation. Or another way is you look at the word cation and remember that cats have paws, so a positive ion would be a cation. I don't know. That was kind of stupid, but whichever way helps. So ions are formed when atoms gain or lose electrons. They have different numbers of protons and electrons. Isotopes exist between atoms of the same element that have different numbers of neutrons. What we're looking at in this picture is carbon-12. It's got 6 protons and 6 neutrons. We add those together to come up with this 12. That's called the mass number for this atom. The mass of electrons is so small that it doesn't factor into this mass number. So this is carbon-12. If we added 2 extra neutrons to this with no charge, we'd end up with carbon-14, 6 protons plus 8 neutrons. So the way to determine the mass number for an isotope, you just add the number of protons and neutrons together. Molecules are formed when electrons are shared between atoms and new compounds are made. So an easy molecule that we all know, water, H2O, it's made of 2 hydrogens and 1 oxygen. So we've got our 1 oxygen in the middle, and it's connected to 2 hydrogens. These lines, those are bonds that represent shared electrons between the hydrogen atoms and the oxygen atom. That's called a molecular or covalent bond because electrons are shared. We can also look at ionic bonds, which form between a metal atom and a nonmetal atom. So let's look at sodium chloride, NaCl, table salt. Instead of sharing electrons, what happens in an ionic bond is the metal atom turns into a cation by giving electrons to the other atom. So this sodium is going to give an electron to chlorine. So sodium is going to have 1 less electron. It's going to end up with a positive 1 charge. And chlorine is going to gain 1 more electron, so it's going to end up with a -1 charge. The electrostatic attraction between these two is what keeps an ionic bond together, but electrons are not shared. The sodium cation donated that electron to chlorine and turned it into the chloride anion. Your question for this section: if nitrogen 15 has 7 protons, how many neutrons does it have?